Okay, welcome back. This is part 2 of integration, and we'll pick up now on definite integrals. Now this is different because it pretty much always relates directly to a graph and the area underneath the graph. Okay, and area has a value, it has a numerical value, a number. Okay, so a definite integral, you will get a numerical answer. It's a bit of work first, you'll have the algebra stage as well, but then you keep going and you actually get a number out at the end. Okay, and what you have when you have definite integrals is bounds to integrate between. In other words, it's sort of a start and a stop. You want to find the area between the two values. So on my little graph here, just for example, look, I've got a graph 0 to 10. If I wanted the whole area underneath, brilliant, that would be written as integrating between 0 and 10. Okay, you put the sort of the start at the bottom and the end at the top. Okay, but if I just wanted to find maybe a thin strip of area, so for instance, for whatever reason, I don't know why you'd want to do this, maybe I want to find just the area travelled, distance travelled between 6 and 8. So I don't want the whole area, I just want that little bit there. Okay, which should be written like that. Okay, now the way this works is quite clever. So what you would do, or what's happening here, let me get rid of all this stuff for a second. Right, what the maths will do for you is it will find, first of all, the entire area all the way up to 8. Let's say, for instance, that comes out as 35 meters, 35 kilometers, 35 anything. And then what it does is it finds the area, but only as far as 6. So maybe that area there is only 19. So the area in between them, the bit I'm shading in blue now, the integral between 6 and 8 would be the difference between 35 and 19. Okay, so it would have an area of 16. Okay, that's how the method works. You put in the two values. So when you integrate, you'll get some algebra. If you put a number into the algebra, it'll tell you the area all the way up to that point. So if I put 8 in, it gives me the area all the way up to 8. If I put 6 in, I'll get the area all the way up to 6. To go in between those two values, I take away the two answers from each other. Okay, it'll make a bit more sense now when we try a question down here. So it says, Dan's got a sketch of a curve minus x squared plus 7x minus 10, and he wants to find the area between 2 and 5, the sort of the positive area here, look, okay, between the x-axis and the graph. In other words, what he wants to do is integrate between 2 and 5, and what does he want to integrate? He wants to integrate that expression, the equation of the curve, with respect to x. Now, initially you can ignore the bounds and you just do your normal integration. Remember now the rule is to raise the power and divide by the new power. So minus x cubed over 3 plus 7x squared over 2 minus 10x, because a number just picks up an x, and don't forget plus c, the constant of integration. Okay, can't really do a lot with that, to be honest. Okay, so what we do is we put square brackets around it. Move this over a bit, otherwise it's not going to fit in. Because we're not finished, and because we're planning on putting some numbers into this to find an actual area, a definite integral, put square brackets around all that algebra, and we repeat what the bounds are, 5 and 2. And then, as I showed you a minute ago, what we're going to do, we're going to put 5 into that formula, Okay, we're going to put 2 into this little formula, this little expression here, and we're going to take the two answers away from each other. Okay, you'll need a calculator for this, so I'll let you do the calculating. So let's put 5 in first of all. So that is minus 5 cubed, as in 5 cubed, but the minus of that, divided by 3, plus 7 lots of 5 squared, divided by 2, take away 10 lots of 5, plus c. Okay, so that's what you get when you, let me move that over, yes. That's what it looks like when you put 5 in. Now we put 2 in. So 2 cubed over 3 plus 7 lots of 2 squared over 2. Take away 10 lots of 2 plus c. And the first thing I'm going to point out is that we don't know what c is, but c take away c, they cancel out anyway, so it doesn't actually matter. All you've got left to do, and you've got a calculator to do it, is get a value from that first bracket, then take away, and move over here. So what does all that come out as? What does all that come out as? Take them away, and there is your definite integral, your answer. Okay, I've got a calculator with me. But type all that in, see what you get. Okay. Now these ones down here, they're also integrating with bounds. We just haven't got the graph drawn. I mean, I can pretty easily sketch one of these graphs though, look. So 4x plus 1 looks something like that. And we are integrating between 2 and 5. And we're going to find the area there. Look, you don't need to sketch it every time. But that's what we're going to be doing. Okay. So, integrating first then between 2 and 5, 4x plus 1 with respect to x, raise the power, divide by the new power, raise the power, divide by the new power, plus c. Oops, little pen thing's not keeping up. 4 divided by 2 is 2, so 2x squared, oh dear, plus 1x plus c. Okay, and then we're going to be putting numbers into this, so at the minute it's an indefinite integral, but when we put in 5 and 2 and take them away from each other, we will get a definite integral. So putting 5 in first. 2 lots of 5 squared, add 5, add c. Well, I can do this one, this is easy enough. 25 doubled is 50, plus 5 is 55. Take away 2 lots of 2 squared, plus 2, plus c. Remember the c's cancel out. So all I've got to do now is figure out what 2 lots of 2 squared is. Well, 2 squared is 4, double that is 8, add 2 is 10, 55 take away 10. The definite integral between 2 and 5 of 4x plus 1 with respect to x is 45 done. Okay. Now then, for this next one you may want to have a little go in front of me if you're feeling confident. Okay, feel free to pause the video and have a go first. So we're integrating between 2 and 4, 6x plus 1 with respect to x, so that becomes 6x squared over 2 plus 1x plus c. I can tidy that up a little bit, 3x squared plus x plus c. Put your square brackets on to say that we're actually now going to make this a definite integral with an actual answer. So we've got, putting 4 in first of all, 3 lots of 4 squared plus 4 plus c. take away 3 lots of 2 squared plus 2 plus c. When you're doing definite integrals, the c's will always cancel out. We've got then 16 times 3, 48. 48 plus 4 is 52. Take away 4, triple 12, 14, 52. Take away 14 is 38. Doesn't really have a unit. You could put units squared if you wanted. Units squared, don't know what I've done there. Units squared. If it was a real life question, because area is distance, then perhaps that might be 45 meters, 45 kilometers, okay. But this is nothing to do with real life. It's not a velocity time graph. If it was, we'd be integrating with t not x in the first place. But the same idea, all you would do is put an appropriate unit for distance as your answer. But if it's just algebraic, if it's just x and y, you won't get away with that. You can just put units squared. And that is how you find a definite integral, okay? So integrate as usual. Remember your plus c. You have to write it in even though it cancels out, okay? Put in your plus c. Then take your bounds, put in the upper one first, then put in the lower one, take the two answers away from each other, and what is left is your definite integral. Hope that helps. I'll put some sheets on to go with this for you to have a little bit of practice and some answers as well. Hopefully you're all staying safe. Okay, be good, stay indoors, don't be naughty.